Okay, this is the P3 paper from June 2024. It's question number 2, and this is an algebraic methods question. We've got some algebraic fractions to look at, and then after that we've got some integrating to do, which it looks like it's going to end up with a log function. But let's look at part A first of all. So part A says we've got this algebraic fraction. Can we rewrite it in this format here? So yeah, absolutely we can. Part A, if we do the long division, so we've got that gx is given by 2x squared minus 5x plus 8 all over x minus 2, and I'm going to take that to mean do the algebraic long division, x minus 2 into 2x squared minus 5x plus 8. So quick reminder, we say how many times does x go into 2x squared? It goes in 2x times. We then multiply 2x by all of this part here. That's going to give me 2x squared minus 4x, and then we subtract all of this expression here. So if I'm going to subtract that, the minus that cancels, a minus and a minus makes a plus there. So we'll get that 2x squared disappears, and minus 5x plus 4x gives me minus x, and then at that stage we bring the 8 down. So we have minus x plus 8 here, and then we do exactly the same thing again. How many times does x go into minus x? We nearly finished the process by doing that. It goes in minus 1 times. Minus 1 multiplied by this thing here is going to give me minus x plus 2. We then subtract that again, and when we subtract that, the x's cancel, but the 8 minus 2 leaves me a remainder of 6. What we need to look at is what we found with all of this here then. So what we've said is that 2x squared minus 5x plus 8 divided by x minus 2, well, it goes in 2x minus 1 times, so that's the quotient, that's the multiplier, and when we do that, it leaves me a remainder of 6 out of x minus 2. So if I just write that down now for the examiner, we can then say that gx works out to be 2x minus 1 and then 6, the remainder, over x minus 2, and then that's in the format that we wanted for part A here. Part B then says, can we use integration to show that the integration of this works out to be alpha plus beta lots of log 3? Yeah, absolutely we can. So part B here, we're going to find the integral between 8 and 4 of gx, which will then be the integral between 8 and 4 of 2x minus 1 plus 6 over x minus 2 dx. Well, if I need to do that, then integrating 2x minus 1, integrating 2x, add 1 onto power, divide by the new power, gives me x squared. Integrating minus 1 gives me that. And then when we're looking at this function here, the integral of 1 over x is log x. So we're going to get log x minus 2. But then because of the 6 there, we're going to get 6 log x minus 2. I would hope that at the stage where you're looking at past papers, that really shouldn't be any issue for you at all. And then we're just going to sub in our values. So subbing in 8 is going to give me 64 minus 8 plus 6 log 6, minus subbing in 4 is going to give me 16 minus 4 plus 6 log 2 here. And then when we collect together the terms, we've got 64 minus 8 minus 16 plus 4. That all works out to be 44. And if I'm just looking at the log functions here, I've got 6 log 6 minus 6 log 2. When we subtract logs, it's the equivalent of dividing them, so that's going to work out to be 6 log 6 divided by 2 is 3 there, and that is in the format that we wanted because they wanted it in this format here. So we found alpha and beta for that one, and that's question number 2 finished off. Not too many difficulties with that one, I hope.